Hello, my name is Nugent, and this is an overview of my ARC 516 research project, Embodied Carbon Calculation for Early Design Stage Analysis. The aim of this paper is to build upon existing research by adapting the Life Cycle Assessment Toolkit developed by Buro Happold and proposing an early design stage embodied carbon calculation tool suitable for use on a domestic scale building information model, which is often rich in unexploited data. A case study methodology is presented in the form of an experimental project on a building of a domestic scale, using a combination of Revit authoring software, Dynamo scripting, and BOAM coding. Why I chose this research topic. With the recent spotlight on the construction industry's contribution to carbon emissions, and after getting an insight into this area during my placement year, I wanted to investigate how designers can utilize BIM programs such as Revit and Dynamo to assess embodied carbon totals at an early design stage. Literature review. The majority of my literature review centered around embodied carbon and environmental product declarations. I had a number of questions which required answers. These included: what is embodied carbon? What are the carbon reduction targets, and are they actually achievable? Should embodied carbon be considered within the early design stage? And can embodied carbon be considered within the early design stage? Also, I wanted to learn what EPDs are EPDs easily available, and how can they be incorporated into embodied carbon calculations. After watching Kaylee Howard's Autodesk University 2020 presentation, I made contact with her and she answered my questions and also presented an embodied carbon calculation workflow which involved using BOAM. It was made clear after speaking with another specialist from Exertherm that gaining knowledge about the properties of materials prior to specification can significantly affect the overall carbon emission rating of a building. By using BOAM, a material's global warming potential can be calculated by easily applying information received from EPD datasets such as ICE and EC3. Case study. With this new knowledge, the case study proposed a process for calculating embodied carbon, demonstrating how information on embodied carbon calculation for materials can be obtained and used at an early stage of the design process for projects regardless of their scale. The case study included 3 stages. Stage 1 involved Revit model development. Stage 2, the Dynamo script methodology. And Stage 3, the visualization of the embodied carbon feedback. The proposal was to adapt the freely accessible open source script, simplifying it for the use of domestic scale projects. This paper explained the development of the adaptive workflow, critically examined its effectiveness, and asserted if such embodied carbon assessments can become an intrinsic component of the architectural design process. Conclusions. Through the adaptation of Buro Happold's original workflow, embodied carbon feedback was obtained and carbon hotspots were identified. This case study indicated that the concrete flooring had one of the highest levels of embodied carbon. In a real project, this would flag that alternative solutions to lower the embodied carbon of this material should be explored. This could be done by increasing the quantity of fly ash in place of the Portland cement. This process seen the seamless integration of Revit, BOAM, and Dynamo to reduce the extent of user input required. This workflow is not designed to replace existing platforms which provide in-depth analysis. It is designed as an early-stage design intervention to help shape the development of domestic-scale projects from a material selection and embodied carbon perspective. Thank you for listening.